Mr. Wara, at your service. Dun, dun, dun. Hey, how are we doing today, my friends? Yes, you guessed it. No, yes, no, what are we doing? I don't know. Yes, we are doing another math video. Well, I should say videos, because we are covering Chapter 5 review, and we have 3 videos, and I'm like, hey, whoa. What's this fellow here? It's our feature animal of the day. Hey, buddy, it looks like a Bactrian camel. Sure does, or at least it looks like it with that look of his face. Very fascinating. And he's got 2 humps there. Wow. I remember when I was a kid, I used to think they were filled with water, and that's why camels could go a long time in the desert without water. And then I learned it's just fat in their humps, and that those camels are pretty special creatures. They can go a long time without drinking water, and they can convert their fat into energy or water so they can survive. Pretty fascinating. Anyway, but are we really here for just you, Mr. Feature Animal of the Day? No, we are here to take a look at some of the material in Chapter 5 of the Go Math. Yes, let's get started. The first question says, Rita is hiking along a trail that is 13.7 miles long. Yeah, I'm just laughing because all the problems that I make up myself have to do with hiking. I love hiking. So, the fact that it's a hiking problem, all right. So far, she has hiked along 1/10 of the trail. How far has Rita hiked? Okay, well, let's go ahead and unpack the problem. The problem here lets us know how long the trail is, that 13.7 miles long. That seems like our total amount, like our whole, if we will. The 13.7 miles can act as our dividend. So our dividend is the amount that's being divided. Kind of acts as our whole in this case. Even though I know 13.7 is a whole part with a decimal part, it's how long the trail is. Now it says that she's hiked along 1/10 of the trail. And 1/10, of course, could be represented as 1/10, right? Or 0.1. Some of you might want to rush and say, oh, okay, I know how to figure this out. I'm going to take my 13.7, because that's my dividend, and I'm going to divide by my 1/10. If you think about the problem, you might think, well, if she's hiking and she's starting at the 0 point, right? And then she starts hiking along, she gets to the point where she's 1/10 of the total trail. You might recall that in previous videos that 1/10 of something kind of suggests multiplication. So we have 1/10 times 13.7. Does that make sense? Because the trail itself is this long, and if Rita's hiking and she's not at the end, or we'd say, oh, she did 13.7 miles, but she didn't. She only went along 1/10 of the way. So we're kind of, in a way, finding 1/10 of 13.7. Well, if you look at that, what is 1/10 of 13.7? Well, we're going to multiply, right? So 13.7 times 1 is going to be 13.7. And then, of course, we just have 10 as our denominator. Well, what problem have we represented now? 13.7 divided by 10. Notice we're not dividing by 1/10, we're dividing by 10. What we want to do is take that dividend, that whole, and we want to make 10 equal parts. Now, what's interesting with the power of 10, and I know many of you have maybe memorized this important skill, and that is that when you divide by a power of 10, that the decimal place moves 1 place to the left. For example, if I just write a random number down here, put as 4.76, if we multiply by 10, that decimal moves 1 place to the right. If we divide by a power of 10, it moves 1 place to the left, and so forth. If you multiply by 100, if you divide by 100, the key knowing that that decimal place just moves. And in this case, this is what we can do. We don't have to set up a long division model dividing. We know that if you divide by a power of 10, the decimal place moves 1 place to the left, which means our answer is going to be 1.37. Now, if all of you are thinking to yourself, Mr. Wara, I was completely aware that I need to do that right away. And that's great if you did. But I also think it's really important when it comes to these types of word problems that we think about what it's asking, that 13.7 was our dividend that we're dividing by, and I think that 1/10 could throw people off. And it's 1/10 of that total amount, so we're actually dividing by 10 because we're using division now, not multiplication. I don't know, I hope that made sense. I could see where some people might get a little confused on that problem. Now we have use the numbers on the tiles to write the value of each expression. You can use a tile more than once or not at all. Okay, what do we have here? We have 35.5 divided by 10 raised to the 0 power. Okay, now I have students all the time ask me, they find this to be very confusing, and one time I did actually explain in length why 10 raised to the 0 power is 1. I think it's something that's introduced here, but not with a lot of detail in 5th grade. When you start multiplying and dividing powers of 10 with exponents, which we don't do in 5th grade, this will make more sense to you. But for right now, I think what's really important that you know, and just think of it as a rule, memorize any non-zero number, and that means not just 10, any number that's not a zero, okay, raised to the 0 power is always going to be equal to 1. And it has to do with how we add and multiply and divide exponents, why this rule is true and how we can show it, but I'm not going to do that in this video. So just know that any base that's raised to the 0 power, regardless what it is, all right, is always going to be equal to 1. So if that's true, then 35.5 divided by 1 is going to equal 35.5. I'm just going to write that in. Now, 10, of course, with no exponent, we know there's this invisible exponent there. That's a 1. So in this case, we have 35.5 divided by 10. Well, we know our rule. When you divide by a power of 10, the decimal place moves one place to the left. So here we're going to have 3.55. Now we have 35.5 divided by 100, 10 raised to the 2nd power, so the decimal place is going to move 2 times. Now you could go ahead and go and figure that out long division, but you'll find that you'll probably make more mistakes than you'd want to make because of the size of the divisor, and the dividend usually causes problems. Anyway, moving on, yeah. Bring on Tom and his brothers. Tom and his brothers caught 100 fish on a week-long fishing trip. Yeah, the total weight of the fish was 235 pounds. That's just me. That seemed like a lot of pounds. But then, of course, that's a lot of fish. So write an expression that will find the weight of one fish. Now assume that the weight of each fish is the same. Okay? Which would probably never happen in a real life problem, right? But for the sake of doing this, so I'm just going to take my total pounds then, and I'm going to go ahead and just divide that 235 pounds divided by the 100 fish. And that's it. That's my expression. I can't put my equal sign here. Mr. Worrell will take points off if you do that. We need just an expression. This is an expression. We're not asked to solve anything. Now we come down to part B. It says, what is the weight of one fish? Now we can see, if we have 235 pounds, and we're going to divide that by 100, which by the way is the same thing as 10 raised to the 2nd power. That means I'm going to move that decimal 2 places to the left. The decimal is right there behind the 5. It's invisible. We usually don't write it in there. So we end up moving 2 places to the left. We end up with 2.35 pounds. We have to ask ourselves, is that reasonable? Yeah, I mean, based on the fact that you have 100 fish, you have 235 pounds, each one being about 2 pounds, that's reasonable. We really need to check for that reasonable of answer. Okay, that meets one of our mathematical practices. Now suppose the total weight of the fish caught stayed the same, okay, but instead of 100 fish caught during the weekend, only 10 fish were caught. How would the weight of each fish change? Wow, I must explain. Whoa, did you just go whoa? This says here, everything else is going to stay the same, the total weight. So 235 pounds is still going to remain. However, instead of having 100 fish, we're only going to have 10 fish. Are you thinking what I'm thinking? Yeah, that's right. We're going to have some really big fish. These are going to be like monster fish, right? Of course that's going to change. How is it going to change? Voicing this out loud before I start writing down my notes, I'm going to say, my goodness, the weight of one fish would really become, well, let's do the power of 10. It's 1 power of 10 less on the fish. So that would mean each fish then, instead of being 2.35 pounds, it's going to be 23.5 because that decimal place is going to move to the right, making it larger. So yes, I'm definitely going to divide the total weight by 10 instead of the 100, which I did in the above problem. So let me go ahead and write that down. The weight of one fish here is going to increase 10 times, right? Because in the problem up above, it increased. We had 2.35 pounds per one fish, and here we're going to have 10 times as much because it's going to be 23.5 pounds. Again, all I did was move the decimal to the right in this case. I would do exactly what I did above, but instead of dividing by 100 fish, I would divide by 10. And that's what we were thinking. If you're dividing by 100, you've got those 100 groups making the number in each one of those groups smaller. But because we divided by 10, there were fewer groups, which means more is going to fit in each group. I don't know if that kind of makes sense. That helps me conceptually to understand what the problem is asking. All right. Okay, let's go on. Dun, 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 dun. Turn. Thank you. Oh, you're back. Draw a model to show 5.5 divided by 5. Because it's just me, or they're really going crazy for the fives there. All right. Well, if we have to have a model, we need a model to show 5.5. That's our dividend. And our divisor is going to be 5. So how are we going to set this up? We need to be able to show 5.5. And that's actually half of one whole. So what you can see here, what I have done is I've represented our dividend 5.5. I have 5 wholes, and I have half, and he's about half of one of those. Try to make it as accurate as possible. Okay, so there's my 5.5. But my divisor is 5, and what that means is I need to make 5 groups and figure out how many of these are going to go into each group. So I'm going to go ahead and do that. Okay, so I'm representing my divisor here with the blue ovals. There are 5 of them because I need to figure out how many of these I can put equally in each one of these groups. And this is what the problem is saying. So if I were to take each one of these, I see that there's 5 of them. So I can go ahead and put one of these rectangles. It looks somewhat like a square, but it's probably more likely a rectangle. So those 5 go in there. Now I have a problem with this one here. This one here I need to split up into 5 equal pieces. Let me go ahead and do that. Okay, now I have my 5 equal pieces, and we're going to just estimate that these are those because I have my 0.5 I need to divide into those 5 equal groups. And each one of these is going to get 1/5 of that 0.5. So now the question becomes, if by our drawing, can we determine what the actual answer is without doing any division? And I think so, because we definitely have 1, so we know it's 1 whole. Well, now we have that 0.5, and that 0.5 now has been divided by 5, giving us 0.1, because 0.1 plus 0.1 plus 0.1, we get to 0.5. Pretty cool. So let's go ahead and put in our 1.1. We always check our work, right? Always allowed. 1.1 times 5. Let's multiply that through. You can see we get 55, but we have that one decimal place in the factor we need to move back into the product. 5.5. Yes. Woohoo! Yeah. Okay, let's move on. Emma, Brandy, and Damien will cut a rope that is 29.8 feet long into 3 jump ropes. See that right away? 29.8 feet. Sounds to me like a dividend, and we're going to cut that into 3 jump ropes. You can see how this is going to be our divisor. Each of the 3 jump ropes will be the same length. Write a division sentence using compatible numbers to estimate the length of each rope. Okay, so when they say write a division sentence, they mean a division equation using compatible numbers. That word compatible sounds very familiar to me. Compatible numbers has to do with numbers that we can deal with easily. Like when you were in 2nd grade, I think I made this example in class, but it was all about making a 10. Saying 6 and 4 are compatible. They make a 10, 7 and 3, 5 and 5. You get the idea. We need compatible numbers so that when we divide it, we can do it easily. Like in our head, so it can sound like a really smart person, right? So 29.8 is practically 30, and 30 is extremely compatible with 3, right? And they're compatible because with the two of them, we can get a good estimate of 10, and that would be 10 feet, all right? Now, that's not our actual answer. It's not our actual. This is our estimate, but we used compatible numbers so that we could kind of get an idea about how long each jump rope would be, and that would be 10 feet. Cool. Carl drove 617.3 miles. For each gallon of gas, the car can travel 41 miles. Good mileage there. Select a reasonable estimate of the number of gallons of gas Carl used. Mark all that apply. But it does say select a reasonable estimate. Okay, well, so I'm going to go ahead and write what looks clearly like a dividend here, right? 617.3. I'm going to go ahead and write my divisor over here so I can look at these two side by side. Because in essence, if I were to take 617.3 divided by 41, I would get myself a result. It would let me know about how many gallons. But the problem doesn't say that. It says reasonable estimate. All right, reasonable. So what I need to do here is I need to take these numbers and I need to, like round them, estimate their value. Here I have 617.3. All right, 617.3. I would like to change this number so that it might work better with this number over here. So 41 seems so close to 40. So if I were to leave that and just say, I'm going to say that's 40. That's so close. Then can I work this number so it'll be compatible with my 4 especially? Well, I'm looking at the 61 and I'm thinking, I know if I were to change this to 64, I know 64 divided by 4 is 16. I just happen to know that. 640 then divided by 40 is just like saying 64 divided by 4 is 16. Because we have a power of 10 here and a power of 10 here, we don't need to add any zeros on, we're good. And 16 is listed here, so I definitely choose D. Now, when it says mark all that apply, sometimes we might think that we actually have to mark another one. Maybe we don't. Well, let's see. Let me go ahead and just draw a line here and keep looking at my top numbers. We could go down the other way. We wouldn't want to go higher than 64 because if we keep going up, 68, 69, maybe you've decided that, like 84 you could take divided by 4. But we're not going to go up. That's making our number not reasonable anymore. What if we went down a little ways? Well, 4, kind of think of 4 and 40. How about 15? So what if we just made this 600 divided by 40? Okay, there's one of those clock problems because a clock has 60 minutes. We divide the clock into quarters, and here's our 4. And if we divide that into quarters, we get 15 minutes. Well, in this case, we're talking 15 gallons, right? Because 15 times 4 is 60. So C is also the reasonable answer. Now, these they're not even close. 1.5 gallons, those are totally unreasonable. And look at this number down here. So that's way off the mark. We're 15 or 16 are close. I mean, one would think that you could almost guess at this one without even doing any of this work here just because it's multiple choice and you can see the answers there. Okay, so I hope that made sense to you, that rounding the number and estimating the number will make it easier in how we did that. Now down below we have Donald bought a box of golf balls for $9.54. Now there were 18 golf balls in the box. All right, about how much did each golf ball cost? Key question it's asking us, about how much did each golf ball cost? So we're not looking for an actual answer. So that means we're going to take a look at, we need a dividend and we need a divisor. Right? We need a dividend divisor, and I see a dividend there. It's $9.54, so we're going to round that one. Now that seems so close to $10, but let me just write this down here because maybe 18 is going to work better. So if we have 18, that seems like we could round the $9.54, I don't know, probably to $10. But if we made the dividend 20, that might work out. So if we had $10 divided by 20 instead of the 18, now that's nice because we have 10 divided by 2. So it's not going to be $5, but it's going to be 50 cents based on a power of 10. And you can multiply that through to double check. If 50 cents times 20 of the golf balls, we have 0, 0, 10. We have 2 decimal places. You can see it brings us back to $10. So yeah, I would have to say that each one would be about 50 cents. All right. And now here we have another problem. Last one. Luke cut down a tree that was 28.8 feet tall. Then he cut the tree into 6 equal pieces to take it away. What is the length of each piece? Again, we keep looking at it. Dividend, divisor, quotients like our answer. So they're all set up the same. We have our dividend here of 28.8 feet tall. He's cutting the tree into 6 equal pieces. Right? That lets you know division. 6 equal pieces, and we need to find out how much then was or what was the length of each piece of that tree he cut. See how that's set up? We keep looking at that, so we're looking at 28.8 divided by 6 is going to equal that quotient. Here's our divisor, here's our dividend. Now in this particular one we don't have a power 10, so we have to just go right to the old long division. In a long division, I'll set that up right here. So what we need to do here first is we need to go ahead and make sure there aren't any decimals in the divisor. There are none. So we're going to take our decimal that we have here in the dividend and we're going to put it right up above. Up, up, and away. All right. So here we are. Now, 6 cannot go into 2, but 6 can go into 28. And we need to multiply by 4, which will give us 24. So we don't put our 24 up here. We put our 4 on the very last digit. We're going to put 24 down here. Now with division we always have to subtract because we're going to have some that are left over. In this case we have 4 left over. But now we still have that 8/10 over here. So we're going to join that 8/10 down here. Okay. Now putting these together, now we have 6 into, in reality, 48/10, and that's going to go in there 8 times, and now we have 48, 0 left over. So then our answer is going to be 4.8 feet. Now again, I always like to get the right answer. Yes, I want to do my very, very best. And so when I do work like this, especially with long division, I implore you to take 4.8 times 6, because now I'm going to multiply my quotient with my divisor to see if I get back to my dividend. Now here I have 48, I'm going to carry my 4, and I have 24 plus 4, which is 28. I have a decimal point in the factor I need to take out, and I'm going to put that back in. Now, did I get back to my dividend? I did. So it worked out. Yoo-hoo, yeah, yeah, yeah. Dun, 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 dun. Dun, dun, dun. Yes, we're done. We have completed the first 2 pages of the review test. Now, my friends, time to say hasta la vista. Okay? Live long and prosper.